Hi, I'm Andre, and today I'm going to be trying to make the sensors for my Uncollapsible Paraglider project. So as you might have seen from the first video, step one is to sense. So we need some kind of sensor to measure the tension on the lines. So let's go back in time to 6 months ago. We're here at Sheffield University. This is where I did my university course in mechanical engineering. We are in the new building where all the engineering departments are, mechanical engineering, aerospace. As you can see, there's a lot of lab equipment around, thermodynamics and whatnot. The first stage of building a paraglider that can't be collapsed is to be able to measure and log the tension on the lines when you're flying. So for that, the idea that we came up with when I reached out to university would be to put strain gauges directly on the maillons. Okay, so before we jump into that, let's look at why we went for that solution. The lines on a paraglider, as you know, are flexible, and that means that measuring the tension is quite hard. There are some systems with 3 rollers, that 2 rollers are the base and the third roller pushes and deflects the line, and you measure that deflection and you work out the tension that way, but they're really bulky, cumbersome. In the case of paragliders, it actually changes the total length, so they're not really right for what we want. So if we look at the tension between the wing and the pilot, there's the lines, but also there's the maillons and the risers. And the maillons are not so flexible and they carry the same tension. So that might make it easier. Let me explain. Okay, so let me show you why we chose the metal maillons for this. So if we look at simple metal bar that we pull apart, as long as we don't go over the elastic range, this metal bar will expand proportionally to the force applied. And that's because of the stress-strain response of metals, in this case stainless steel. So if we look at that, this is not exactly correct, but it's more or less. If we look at metals like stainless steel, they usually have a stress-strain response something like this, which means there's this elastic region over here where if the force gets this high and the force then gets taken off, it's linear and the material recovers. And then there's this part over here that is the plastic response, in which case if the force goes so high that it goes to here, that damage is never recovered. So this is definitely something you've seen before. For instance, with a paper clip, you can push it so far and it will always regain its shape. It will spring back because we're in the elastic range. But if you go too far and put too much force on it, it will deform it and it won't go back. It will only go back a certain amount. So that means that this part here has been stressed past its elastic range and into the plastic range. Ah, look at that. That's kind of the same shape. Anyway, so the important thing here is, as long as we stay below a certain level, we know that strain is directly proportional to stress, or to force applied, in this case the tension on the line. So all we need to do is to measure the strain. Okay, so luckily engineers already developed these things a long time ago. That's a strain gauge, and just to show you how small that is, here's 1 pound. Let me change lens and we'll try to get a close-up of this guy. So this is the strain gauge close up. If you see, we have kind of weird zigzag pattern over there. This is the part that we're interested in, and these are the 2 terminals that we can connect to. Okay, so all that a strain gauge is is a very well calibrated resistor. It has two big terminals that you can connect to over here, and then in the middle has some very thin lines. So these very thin lines is where the resistance comes from. So if we connect this strain gauge, if we mechanically attach this to our maillons, as the maillons stretch under tension, these small filaments will also stretch, and that means that this resistance of those filaments will change. So if we measure this resistance, we're measuring strain, and if we're measuring strain, we can calculate the force that is generating that strain in the material. So at this point you know where I'm going with this. You get a maillon, you attach one of these strain gauges to that, one wire to each of those terminals, you measure the resistance, and that's it, you're done. Well, it's not as simple as that, because how much this resistance varies is very, very small, and measuring it is very hard. So that's the problem I will tackle in the next video. So that's it. I now have my makeshift sensors for measuring tension on the paraglider, and on the next video I'll see if I connect some electronics to these and make them useful. Thank you so much for watching. Don't forget to subscribe if you haven't already, and I'll see you later. Bye.